Let's stick with some UK style questions. All right. So the first one is up. And most of the questions, as with most of the questions today, I'm looking at the list. It's from Key Stage 3 Sats. This is back 2003. Yeah, 2003. So 17 years ago. This is the exam. These are some of the questions young people have been doing. So wow, it's 70. So people did this. They're finished university. Yeah, some of them might be moms and dads now. 17 years ago, if you were 14, and depending your ability where you're at Mats, this is what the paper you would have had. And I'm saying, you know what? Yeah, a lot of time has passed. A lot of things have changed. And this is kind of stuff you can be able to do when you're in year 4, year 5, even before that, year 3. Yeah, you can pull this off. Year 3, yeah. Okay, so off you go. You're reading it, and yeah, I'll do my bit. You know, the usual. For the first time, you always have to prepare for people who've been here the first time. And if it's the first time, you try the problem. I do the problem after in incredible detail as necessary. And what I'm trying to do my very best is to stay quiet, to learn to stay a bit more quiet so you have time to focus on your problem a bit more. But I'm battling with the idea that, well, hey, it's a live stream. If I just have the question up and I'm not doing anything, it looks a bit silly, you know? And it's not like class where I can be walking around and I can see what students are doing, and based on what they're doing, I'm thinking, this is what I'm gonna do next, or I'm gonna do the other thing. So this live stream thing is tricky, you know. It's tricky, but we gotta do what we gotta do. Okay, so right. Okay. I'm gonna occupy myself with doing the question. But if you've read this, yeah, read the question. Read quick. You should have your answer real quick on this one. Teacher. So the teacher takes a card at random. Let me get my key ideas on this one. Oh, can't write. That's not very helpful, is it? Okay, right. Can write now. Done. Yeah, I just highlighted the two things, so I'm not gonna say. I'll get, and then that. What do you want? What do you want to do? If you need the power of the pause, use the power of the pause. But me, yeah, sorted. And when I by that, it's a live stream that can be paused. So if you pause, you need to pause it to think about it a bit more. That's great. But you see what I've highlighted there, all that fluff and all that reading. Well, actually, it was important, but the picture deals with this. That it's five number cards. They've highlighted all the keywords, different positive whole numbers, certain it's number less than 10, impossible that it's even. Okay, so they highlighted some of the keywords already, and all this actually means, well, hang on, just write down the first 5 odd numbers, can you please? The first 5 odd numbers: 1, 3, 5, 7, 9, and let's check, does that work? It's impossible that the card showed an even. Is that true? None of these cards are even. Okay. It is certain that the card would be less than 10. Is that true? Yes, all the values are less than 10. Each card shows a different number. Yes, all the numbers are different. And are they positive whole integers, whole numbers? Yes, they are positive whole numbers. So done, sorted. That's your numbers. A lot of fluff trying to, or a lot of detail just trying to get through to home into you. What are the first 5 odd numbers? That was your strategy there. You like that? You like that? Yeah. Okay. Let's move on to another one. Shall we do another one? Should you do another one? Now this is a very this is a very important question. You know, everybody, this is very important mathematics you're about to do, and you actually need to do some mathematics calculations. Don't rely on what you know or what you've heard mommy say or daddy say in terms of how much water you're gonna drink. Based on the information provided on the screen, that's what I want you to use to work out how many glasses that you drink each day to stay healthy. So off you go on that, and I'm gonna prepare. I have an idea how to Yeah, I'm gonna prepare myself for explaining this in a moment. Me. Not talking. Not talking. No talking. People are doing their work. Don't talk. Be quiet. Beep at the book. Beep at the book. Oh man. Yeah. Okay. Right. 225. You got something? Okay. I'm gonna do T minus 10. And remember, you don't have to work on my speed. You can use the power of the pause, and do put in comments as well. I do look at the comments, and you know, I mean, I'm busy thinking about the mats and all of that, just like you. But I am gonna try to I look through, and you'll get if I like what you're saying and what have you, and I'll provide commentary. So do get involved. Do post comments, even if you're not watching live, you're watching later on. Hi, sorry you couldn't be here when I was here, but it's all good. It's all good. We want to communicate with each other. Let's do this thing. Let's do this thing together. The first thing in this question, the first thing you're interested in sorting out in this, 1.8 liters, 225 milliliters. Can you see a bit of a problem there? It's not the same units, and the only way you can actually successfully do this question is if you could do a conversion of units. So what you need to be aware of is 1 liter is equal to how many milliliters? 1 liter is how many milliliters? Exactly. It's 1,000. So 1 liter is 1,000 milliliters. 1 liter is 1,000 milliliters. And if that is the case, then 1.8 liters is going to be 1.8 multiplied by 1,000. And 1.8 multiplied by 1,000, well, that will give me 1,800 milliliters. So what we're saying is an adult needs 1,800 milliliters of water each day to stay healthy. We know how much a glass holds, and now we want to know, well, we want to know how many glasses, so we want to know really how many 225s go into 1,800. So we need to do 1,800 divided by 225. And I hope you are not even thinking about bus stop method or any formal division. You could, all the best to you, because that's inefficient. Look at what happens with these numbers. Look at how it happens. These numbers, they're nicely related to each other. If I double, multiply by 2, and let me put that in red. If I double 225, if I multiply it by 2, I get 450. Are you seeing where I'm going with that? If I double again, multiply by 2, what's 450? If you double 450, what do you get? 900. And by now, it should be game over. 900, 1,800. Yeah, if you double again, you're going to get that 800. So what did we do? We had to go from 225 to 1,800. We had to multiply by 2, then multiply by 2, then multiply by 2. We had to double 3 times. So how many glasses do you need? 2 times 2 times 2, which is 8. 8 glasses are what's needed. And for me, I think this was the pattern I spotted. I think this is the most efficient way. If you did it a different way, would be happy if you describe that to me. Because we're always thinking about not just getting the question right, but thinking about spotting relationships and efficient methods. That's a big concern about what we're doing as well. So yeah, that's a nice one. I enjoyed this one. It's talking about water. I'll be honest with you. I do not drink enough water. Something I need to work on. I don't think I'm doing 1.8 liters. I need to drink 8 glasses of water every day. I probably do about 5 or 6 most days, to be honest. Not good. Okay, right. Now, read through. You see what you come up with on this one. Yep, you read through and then come. After all that, that one did my mind in. Okay, take a break. Drawing lines straight sometimes with this thing. That's much better. And the idea that should have come to your mind, remember, I'm going to start talking about it, but you have the power of the pause. So you can stop me dead in my tracks. Yeah, you can, or you can slow me down anyway. If we're talking about share cubes equally between 9 people, that's what you're looking for, the 9 times tables. You're looking for a number in between 20 and 30. That's what we said, between 20 and 30, but it has to be in the 9 times tables. That's what sharing equally by 9 indicates, a number. So that's what you're thinking about. So what number between 20 and 30 is in the 9 times tables? 9, and if you start going up, 9, 18, that's right, 27. So the answer for the first part, how many cubes are in bag A? Bag A is going to have 27 cubes. And then for bag B, same answer. Share equally between 4 people, And for sharing equally between 4 people, what numbers are in the 4 times tables? Now how many cubes could be? Note the language difference. How many cubes are in? Because there's only one answer, 27. But here, how many cubes could be? There's 2 different answers. Language, be careful with your language. 2 different answers. And the answers, the values you're looking for. 4 times tables, what do you have? You have 24. 6 4s are 24. Or the other number is 7 4s, 28. 24 or 28. You could have 24 or 28 cubes in bag B. Okay, language and use your language carefully to interpret your language carefully to get hints in your questions. Okay, to help you solve your problems. And that is, we did good. Right, thousands digit. What's the value of the sum? Ooh. Sorted. I got it sorted. I'm ready. Note, you did not need to do the sum. What you doing the sum for? I didn't ask you for the answer. You don't need the answer. What are you doing? And I'm gonna do it. You have the power of the pause. If you want more time, use the power of the pause, and you can make me can't hear me if you pause me. Yeah, right. So I know all you just got to check is your carryovers. Is there going to be a 1 over? There's none. There's a carryover 13, carryover 1, 12, carryover 1. That's all I'm thinking about. The 1 goes over, which means that I will have 7 and 2 and 1, which is 10. I'm going to carry over 1. Not interested in that. Question is, what's the thousands digit? The digit you're going to end up with in the thousands column is a 0. Big fat 0. The answer to the question? 0. Okay, that's what you were looking for. You had 9. Is there going to be a carryover from the previous column? Yes, there's a carryover. So that means that 9 is going to become 10. You're going to be left with a 0 in the thousands column. Let us move on to another one. Real quick. Boom, 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 boom. Bow. Got to read this time. Got to turn numbers into Sorry if I was too fast in the other one. I was a bit excited. Sorry about that. Sorry. But you did have the chance to pause. Yeah, you did. Yeah. So it's all good. Right, what is this thing there? Use the power to pause if you need to. And I am going to visualize it. Visualize it. What numbers? 337,000. That's what it looks like. 1,000,160s. And ooh, I'm going to get my zeros. I'm just going to put that in. And all you need to be thinking about is from 137, how do I get up to 1,000? Okay, and the 7 I need to add on. I'm thinking 37. How do I turn that into 100? I'm gonna put 8 here. I'm gonna have 8 and 9. That's 900,000. I'm at when I put the 8 in the 100,000s column. 900,000, and then okay, 37. I can scale this nicely. 6 and 3 is 9. 7 and 3 is 10. Look at what we're getting there. That's it. That's the answer sorted. Note, I did not go into any carryover or anything like that. My strategy was, I was thinking 137. I want to get up to 1,000. I know it's 1,000 is what a million is. I have 137,000. I want to get up to 1,000 thousands. Woo, did you hear that? Woo, somebody was messaging me, but you got to hold on. Don't know who it is, but we'll come back to you. Pause. Right, and 137, you're scaling up to 100. You can scale up to the nearest, different way you could think about it. I'm just showing you different ways. It's could have scaled up to the 140. That's adding 3. Then scaled up to the 200. That is adding from 14 tens to 20 tens. That is 6 tens. So you're adding 60. That's where the 63 is coming from. And then when we're at 200, we can scale up, add on 800 to get to 1,000. That's how my brain works. Does your brain work some way similar to that? I'll be honest, even when it comes to subtraction, the whole did you do, is anybody out there, you're doing, can't take away, 0 can't take away 7, can't do it, so borrow 1, carry over 1, 10 take away 7 is 3, 1 take away 3, can't do it, borrow, what am I doing now? Did I do this thing right? You know what, I'm actually confusing myself. I can't borrow. I gotta borrow from the 10, make that 9, make this 11. Whoa. You know, I've even confused myself with this thing. What is this? This carryover method? Oh my goodness. It's a scandal. How do you do this? Oh, now I remember. I was doing nonsense. This is hard. What do you call it? What do I call it? The carryover method is hard. It's a bit of voodoo. I actually take from one. What? I have to borrow 1, make this 0, then make this 10, borrow, make that 9, make this 10, borrow, make that 9, make this 10. Oh my goodness. Seriously? The brain doesn't operate like that. Now I got it right. 10 take away 7 is 3, 9 take away 6 is 3, 9 take away 1 is 8, 0. Oh my good. All of that jazz, that algorithm is like, no. Something for you to consider using your number line in scaling up. How much more do I need to get to 1,000 is perhaps a better way to think about it. I'll leave that with you. You know, the algorithm, that borrowing is borrowing. Yeah, borrowing might have its place. I know. Oh yeah, in the Stone Age. That's where it probably has its place. Ooh, did I just say that? Yeah. Don't tell your teacher in school. Actually, you know what? You can, and let them pop an email to me. I'll deal with that. Let's go on. Let's move on. Moment there. Okay, right. Let's talk about me. Right, you got a question there about me, Dwayne and Wayne. Y'all like that? Yeah, I got another one of these coming. Later on, we got a question with Mumbo and Jumbo. They're featuring in Mats with Mr. D. Mumbo and Jumbo. But for now, it's Dwayne and Wayne. How far do I live from the cinema? Let me see what you come up with there. What's the shortest possible distance? Yeah, so you read the question. I'm giving you time to read the question. So I need to zip it. Don't talk, man. You got something? If you don't have something, you have to use the power of the pause. Okay, you gotta use the power of the pause. So go on, stop me. Dun, 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 dun. Pause. Yeah, power of the pause, and let me do this thing. A picture is worth 1,000,000 words. I was going to say 1,000, but given that we did a question with 1,000,000, a picture is worth 1,000,000 words. So you got to visualize. And I'm going to visualize. What I'm going to do, I think I'm going to visualize this problem deeper than even you visualized it. Even if you have the answer right, I'm thinking I'm going to go a bit deeper because did you actually really consider the problem fully? You know, that's what I want you to do that, yeah? So what might seem simple, and yeah, do your dance if you have the answer. The answer's 5, by the way. If you want 5, yeah, 5. But did you really think about this answer deeply? Look at this. I'm going to draw a picture here, and I'm going to say this is Dwayne. Dwayne is here, and Wayne is over there. Okay, and that means that distance from Dwayne to Wayne, we know that distance is 8, we were told that it's 8 miles, yeah? So 8 miles. That distance there, I'll just put 8 miles. Let me put that 8 nice and neat so you can see it, 8 miles. Now, with that, so that's tick. We have a picture representing that first set of information. Now, if I ask you to draw a picture, if I ask you to add a bit to this picture to indicate where the cinema could be, what would you draw? Didn't expect that. Insert that into your picture. Add a bit. Whoa, something almost fell down there. Just you add a bit while you're doing that. Let me just fix this. Whoa, on live, come on, this is live stuff and you're doing this. Oh my goodness, that would have been a disaster. Do not fall. It's all good. I'm here. It's all good. So draw a picture. That would have been if that thing fell down, you would hear bang da dan da dan. That's like some robots and stuff. That would have been ugly. Just stay. Okay, right. Let's go on. Right. So you got me thinking. I lost my chain of thought there. Okay, right. You got to be thinking. Draw a diagram. I'll give you a moment. Draw a diagram that you think can represent where this cinema could be. That's what I was asking you to do, and I'll give you take 5-10 seconds. Just draw. What can you represent for where the cinema would be? Now I'm going to draw mine. And this is what I'm going to do. To answer the question, you need a circle. I can't really fit a circle in here, but hopefully you can. It's a circle. You see, the thing is, did he draw a circle? Circle. Yeah. See, the thing is, Wayne lives 3 miles from the cinema. Okay. Now, the truth is, it's the same thing. I could have represented Dwayne and Wayne with a similar thing. They said 3 miles from each other. We didn't say in what direction, but I put it there. I left that. But I could introduce the direction thing here now. I should have done a circle for D as well. Yeah, but that would have overcomplicated it, but I should have. The thing is, it could be in any direction. So, for example, the cinema could be here. That could be the cinema, and that distance there could be 3. The cinema could be here, down here, 3 miles to the, that is about southeast. 3 miles north, it could be 3 miles southeast. You know, it could be down there. That could be the distance there. What I've done is a circle with a radius. So the distance from Wayne is the center of the circle, and the radius of the circle. So the distance from the center to the what we call the circumference is 3. I'm just throwing out deeper ideas. You might be familiar with some of that terminology. If you're not, don't worry about it. I'm just throwing out how we go about building mathematical models of problems. And where you might not be thinking about it like this at this stage, but as you develop, as you work with me more, you'll see you'll change your perspective on things. This is the kind of stuff engineers have to deal with. You're interested in engineering? This is the kind of stuff they're doing, you know? So it could be anywhere. It could be here. That's what, 3 miles. That it could be 3 miles, and that's what is that? Southwest, or it could be going down this way, 3 miles, or it could be going this way. It could just be heading 3 miles east. Okay, the cinema could be any of those positions. Any point on the circumference of the circle could represent where the cinema is. We want the shortest possible distance, and the shortest possible distance is going to be as if the cinema was heading in the direction of Dwayne's house, 3 miles out in the direction of Dwayne's house. That's where you'll get the shortest distance. And if this is the shortest distance, which is what, if you have 5, that's the way you were thinking about the problem, and I'm just throwing out, did it cross your mind about the other possibilities? Okay, did that cross your mind at all? Because you need to be thinking, have you considered the problem in its totality and then stripped away the bits you don't need to consider? So shortest distance, it's 3 miles in the direction that Dwayne is, which means it's 3 out of 8. It's reduced the distance of Dwayne by 3. The distance from Dwayne to the cinema is going to be 5. If this bit here is 3, it's 3 miles in this diagram, 3 miles to the west of Dwayne is what I put there, then the distance from Dwayne to the cinema is going to be 5. Okay, and that is your answer to this question. What's the shortest possible distance? 5. As soon as you start to go in a different direction from Dwayne's house, you're going to be increasing the distance. Okay, and if you don't believe me, get a ruler, draw the diagram, and check it out for yourself. You're going to be increasing the distance. Now, one day I'm going to ask you what's the furthest distance, but not today. Not today. Don't get away with that. Right, let us move on. How we're looking for time? 14. Do we? Boom. Yeah, let's do this. Boom, shaka, laka, 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 laka. There's a couple of interesting ones I want to make sure I get in, but I can't remember which one it was. There's so many interesting ones. But, okay, right. We're up with this one. By the way, I didn't mention it, but we have been living in America all for the whole session so far. All these questions, not the last yet. Well, the last one kind of inspired. It's inspired by some American stuff I use. These are questions from American competitions, and I'll be honest with you, the Americans actually, when it comes up to the big Olympiad. Am I right in saying that? Oh, you know, I can get no. I'm gonna say the Americans do beat the UK in the big Olympiad, and I think I'm right. I'm right. UK MT, Matt's Trust. If I've made a mistake, I'm sorry. I should know better. But yeah, I think the Americans generally come higher up on us. They got lots of competitions in the US, and these are international competitions. Anybody can enter. You know. But yeah, so feel free and give me a buzz if you want to talk more about that. But for now, do the question. Question of champions. Right, if you want to be so kind to work this out, please. What are you gonna get? Never saw one like that. Teacher never gave you one like that. You think you're some expert at adding and subtracting fractions? Let me see you now. Yeah, real challenge. That's what we offer. That's what we're talking about. Zip it, Mr. D. 1. Do your work. Stop disturbing me. Do your work. Do that first. See, I'm here to help. Do that first. If you're wondering what to do, do that first. Okay. Now let me make it clear. A bit clearer there. Try to make it clearer there. That's your process, your order of your operations there. And you have to power the pause now if you don't want to watch the D. Do it. I got my pen. I'm ready for this. I'm gonna do it. Yeah, I am. So you had your chance to pause, right? I did do the denominator. Work out, simplify the denominator first. So you have 1 take away 2/3. And well, 1, the only way you can subtract fractions, I'm taking a pragmatic approach to this, is if the denominators are the same. So I can just say that is 3 out of 3. That's what 1 is, 3 divided by 3, because the fraction bar means to divide. So 3 out of 3 take away 2 out of 3, which is 1/3. So tick, I know that value is 1/3. The question is actually 1 plus 2 divided by 1/3. Note what I said. I didn't say 2 over 1/3. I said 2 divided by 1/3. The fraction bar means to divide. So what's 2 divided by 1/3? And I'm just gonna take a visual approach to that at this stage. I'm not looking at bringing in very formal methods for division. If you want a formal method and what you probably hear in school, KF, no, not that one. I'm not even gonna say that. I'm hungry. Damn, I'm hungry now. I'm very hungry. I shouldn't have done that. Oh, man. Okay, KCF, KCCF. The strategy you might have heard in school is keep change. Why am I doing that? Cheap change flip. That's something you might have learned in school. If that makes sense to you, great. Keep change flip. That's what it's supposed to look like. KCF. But the strategy I'm going to take is, let's use deep understanding. Let's just take a visual method to what is, we're working out this, what is 2 divided by a third. If I have 2 wholes, and I want to share it into thirds, how many pieces will I have? That's what divide means, share it into thirds. Well, the first one, I'll get 3 thirds. 1, 2, 3, I've shared it into thirds, I get 3 parts, and the second one, I'll get another 1, 2, 3 parts. So, that means that 2 divided by a third is equal to 6. 2 divided by a third is 6. And finally, the third, so this was the second part of the question, this was the first part of the question. And then the last part of the question for us to finish our job here is 1. Well, all you end up with is, what is 1 plus 6? And 1 plus 6 is 7. 1 plus 6 is 7. So 7 is the answer, and we are sorted. We are sorted. Okay? Right. Never did one like that. Did you enjoy doing one like that? You can do more like that and either other interesting challenges. That's what Maths Club, Raymondson Maths Club is all about. And let us leave America. Let us leave the land of the brave. The land of the... I can't remember any other script from a movie. But let's go to England 2019. This was a nice one. This is a key stage, end of key stage 2. So year 6, which is grade 5 in America. Yeah, so foreigners out there, grade 5 in America, the American system, grade year 6 in the UK. And this was a question, I remember a couple months ago, I gave this question to, I think some students in year 9 or year 10, not middle students going towards a foundation exam paper, and they struggle with this one. How about you? What are you gonna do? You have your time. You won't get full time on it. I'm conscious of yeah, but you got your time. Let me see what you come up with on this one. Off you go. I got my pen and paper. I'm gonna work on it as well, and then we'll talk about it. I'll go through it in a lot of detail. Okay. First of all, what I'll do, I'll highlight the key. Had a chance to read. I was going to use the digital pen to write on paper. Let's see how that would have worked. Okay, so I've given you some help there. Hopefully that can help you there. Okay, you ready to talk about it? If you need more time, you have the chance to yeah, you have the chance to look at it. You have the chance to use the power of the pause. Don't worry about it. You know, live TV, live shows can be paused as well, and give yourself more time to take ownership of the problem. Now, the key thing, I highlighted it here. The distance from point P to point Q is 4 times the distance of. So this distance, P to Q, is 4 times the distance from Q to R. Well, that didn't look good. That's not good. Q to R. That's what we're saying. So I like the idea of building that. That means that if I was to chop this line into parts, Q would be 1 part, and QR, this will be one part of the line, and this will be four parts because it's four times bigger. So that's the way of looking at it. If this is one part of the line, this, whatever length this is, this has to be four times bigger, so it has to be four parts. So I want to think about this line being cut into 4 plus 1. Look at it, 4 and 1. You have to cut the line into 5 equal pieces, where one piece is QR, and then I need to cut this into 5 equal pieces, 4 pieces. PQ has to be cut into 4 pieces. Each piece is the same length as QR. So the line is cut into 5 equal pieces. And I'm looking at this and I'm thinking, definitely not drawn to scale because I ain't going to pull it off. But 1, 2, 3, 4, and 5. Okay, they're supposed to be, and let me write it down. It's 5 equal, very important, equal pieces. 5 equal pieces. QR is 1 piece. So if I got a line, the length of the line is 800 meters, and it's cut into 5 equal pieces. And PQ, this length, is worth 4 of those 5 pieces. I think I've said enough there. It should be a game over situation now. You want to know, well, what's the length of one piece? And then you multiply that by 4 to get the length of PQ. So one part, it's 5 equal pieces. How do I cut 800 meters? 800 meters in length to be cut into 5 equal pieces. How do I do that? And I hope that comes clear in the diagram. The 800, let me just make that super clear. The 800 is the whole thing. And the mistake, you can see what the 800 is the entire line. 4 parts of that, 4 out of 5 parts is 8 is what PQ represents. I hope I haven't muddled that up. I think I've said it right. So I want to share, first thing you'll do, cut the line into 5 equal pieces. So one piece, I would put one piece, and then brackets I could put QR because one piece is the length. QR is going to be equal to 800 divided by 5. I'll use my bus stop method. How many 5s are in 8? 1. Remainder 3. How many 5s? I can't even get that 3 to fit in there. My goodness. That's a 3 there. How many 5s are in 30? That will be 6. So 16. And then I have a 0 remaining. How many 5s are in 0? 0. So 800 divided by 5 is going to give me 160. That means that this length here is 160 meters. But we're not interested in that. The question is talking about is it is 600. The person said, Olivia said, it's 600 meters from P to Q, PQ. But actually, and we're going to see if she's right now, it's actually one part is 160. So the 4 parts has to be 160 multiplied by 4. And we ain't going to get 600, are we? If you do 160 multiplied by 4, 16, you double 16, you get 32. You double it again, you get 64. So 16 times 4 is 64. 160 times 4 is 640. It's actually, PQ is 640 meters, not 600. So is she correct? No. And we have shown working to indicate that PQ equals 640 meters. It is 4 times the length. It's 640 meters. That is the answer to the question there. 640 meters. That's what we're looking for there. Okay? Hope that was good. That was good. That was good. This is a fun one. And we are going to, where are we going to finish today? We are, got 3 minutes. I got 3 questions to choose from. Obviously, different lengths and difficult levels of difficulty. Should we go back to America? Do you want to finish with an American one? Thing is, I can't remember what the American one was. No, let's go bonus round. Let's go primary match challenge bonus round. That's what we're going to finish on. Boom. Mumbo Jumbo. Because I told you about Mumbo Jumbo, so I think this is a nice one to finish off. Mumbo Jumbo. We'll finish off with... Yeah, we've kept it lightweight thinking, nice thinking is what that's the sort of sense I've played it today. It's Friday, we're chilling and just stimulating the mind. Silence from me. You have information about Mumbo. You have more information about Jumbo. I came up with those names, by the way. That wasn't what was in the actual challenge. So I've modified the question. It's inspired by theirs, but Mumbo and Jumbo. That's cool. Yeah, Mumbo Jumbo. I'm so proud of myself. Ooh, creativity. People say maths people are geeks and boring and all of that. I ain't no. Well, I am. Fair enough. Let's not call that. Right. Off you go. See what you can come up with. Let's round things off. Need a bit of help for first thing. Let's. Okay, and I'm gonna start talking about it. We're gonna go a bit off 30. Yesterday I was bang on 30. As soon as it got 30, I just cut. It was good, yeah. Right. You gotta convert the units. The only way you can work this question out is if you have the same units. So remember, use the power of the pause if you want to continue working on it. So we want to convert the kilograms to grams, and what 1 kilogram. You need to remember that 1 kilogram is 1,000 grams. So if I have 3.03 kilograms, I need to multiply that by 1,000. 1, 2, 3. We visualize this idea of the decimal point moving. The decimal point is like a rock. It never actually moves. It's actually, when getting bigger, it's the numbers shifting to the left. But it's easier to think about decimal point moving. I need 3 spaces, so 0, 3, and to fill the last space I need to put a 0. So the value, bring down that 3, it's 3,030 grams. 3.03 kilograms is 3,030 grams. So now we want to know, if I want to know how many times heavier, I want to know, the question is now asking, and step 2 really is, how many times can... step 2, yeah. How many times will... How many 0... I was just going... It's a division problem. I was thinking, sometimes you're thinking, how do I frame this to make it clear? I want to know how many times I can get 0.03 in 3,030. And how many times a number goes into another number, that's division. How many 0.03s do I have in 3,030? And the golden rule is... You don't divide by a decimal. Don't do it. Don't do it. Don't try to do it. It's painful. Not saying it's impossible, but yeah. You know what? To be honest with you, I haven't even tried. You know, just don't go there. You want to use you want to. This is the idea you want to use, and how you work out questions like this. Well, we know that if I have 2 times 3, I'm gonna get. Actually, it's division. So let me stick with division as my idea. What we're gonna do, I'll just tell you what we're gonna do, and then I'll show you why we're gonna do it. Going over. We're gonna multiply 0.03 by 100 because we want to divide by a whole number. And to ensure that we do not change the answer to the question, the multiplication I do to my divisor, the number I'm dividing by, I do the same thing to the number that's being divided. Okay, so I'll multiply both of them by 100. And that does not change the answer. Changes the value of the numbers in the division, but it doesn't change the answer that we're going to get. It doesn't change the how many times bigger we're trying to answer. Because look at this. If I have 10 divided by 2, the answer is going to be equal to 5. If I was to multiply both of them by 10, I now have 100 divided by 20. The answer is still 5. So once you do this, use this strategy, it does not change the answer, but it does make the question easier to work out. And that's a big idea you need to use throughout your mathematics. Sometimes the form you get the question in is too difficult to work out the question, And using your understanding of relationships between numbers, you can relationships between the operations of numbers, the 4 operations, you can change from one form to another to make the question easier to do. And that's a big strategy. So my strategy here is multiplying both of them by 100. I'll take off my reasoning here, and then I'll look at finishing the problem. So my problem finishes with I'm multiplying 3030 by 100, so that is now 303,000, and I'm going to divide it by, when I multiply 0.03 by 100, I'm dividing it by 3. Easy, easy peasy. Job done. Answer sorted. You start the division, and I could have set it up by the bus stop method, but this is so straightforward. I hope you feel the same way too. How many 3's go into 3? 1. How many 3's are in 0? 0. How many 3's are in 1? How many 3's are in 3? 1. And then we have the zeros. The answer, 101,000 times. Jumbo is 101,000 times bigger than Mumbo. Whoa! Jumbo is really jumbo. Oh, Mumbo is really mini Mumbo. Okay, right. I'll leave you to think about that. You know, is 3 kilos actually that big? It might not be that big to us, but what about Mumbo if Mumbo is a teeny weeny ant? Oh, that changes things. That changes things a lot. I trust you enjoyed that. Trust you enjoyed that. I enjoyed it. I love solving problems. Hope you love solving problems.